talk about quantum numbers. There are four quantum numbers: principal quantum number, angular momentum quantum number, magnetic quantum number, and last one is spin quantum number. So let's talk about each quantum number and what are the meanings or what are the things related to each quantum number. First one is principal quantum number. Symbol is lowercase n. So principal quantum number relates with the energy of the orbital. And in many electron atoms, that means electrons more than one, that is not hydrogen except hydrogen, it tells us the average distance of an electron from the nucleus. So principal quantum number can have value n is equal starting 1, it can be 1, 2, 3, 4, any positive integer and so forth. Right? The lowest value is n is equal 1. So you will know its nucleus in the middle in the atomic structure, and the next, the closest energy level to the nucleus is we call n is equal 1, and the next energy level, next highest energy level is n is equal 2, and next highest energy level we call n is equal 3, and so on. It can be 1, 2, 3 or any higher number. So if the energy level n value is greater, larger, that means the electrons are very far away to the nucleus. If electrons in n is equal 1 level, it is more closer to the nucleus than electrons resides in n is equal 3 level. That is the meaning of principal quantum number n. Let's talk about carbon. Carbon atomic number is 6. So we can write the electron configuration 1s2, 2s2, 2p2. So in this electron configuration, how many electrons are in n is equal 1 shell, that is the shell closer to the nucleus. Shell, or another name is energy level closer to the nucleus. So this n value is indicated here as the number in the electron configuration. So n is equal 1 level, that is the closer energy level to the nucleus, only 2 electrons occupied. And next highest energy level is n is equal 2. So n is equal to how many total electrons occupied. So n is equal to level, there is s subshell and also p subshell, both are here. So in s subshell 2 electrons and p subshell 2 electrons. So total 4 electrons in n is equal to energy level. So carbon is made by 2 electrons occupied in n is equal 1 energy level and 4 electrons total in n is equal to energy level. Okay, now let's move on to second quantum number. Second quantum number is angular momentum quantum number. Angular momentum quantum number symbol is lowercase l, and that relates to the shapes of the orbital. So we discussed in last slide, and you all know orbitals are different shapes. Example, s orbital is a dumbbell shape, spherical shape like a sphere, and p orbitals are dumbbell shape like dumbbells, and d orbitals, most of the d orbitals in 3D level are clover leaf shape. Right? But dz square is different, but the shapes looks like this. So angular momentum quantum number tells us that relates the shape of the orbital. Now let's see how we can find out L values. So L values is depend on the principal quantum number n. L value depend on principal quantum number n. For a given n value, principal quantum number, L values can be 0 to n minus 1. So possible L values are 0 to n minus 1. That means L is depend on the principal quantum number. So let's see, if n is equal 1, there is energy level closer to the nucleus. What are the possible L values? 0 to n minus 1. So only possible L value here is 0. If n is equal to The possible L values are 0 to n minus 1. N minus 1 is 2 minus 1, 0 and 1. And n is equal to 3 energy level, third energy level, L values possible are 0, 1, 2. And n is equal to 4, possible n values are 0, 1, 2 and 3. That's how we can find out L values are 0 to n minus 1 always. Now, what are the names of these L values? So, L is equal to 0, we call S orbital. S orbital is L0. And P orbital, L value is 1. And D orbital, L value is 2. And F orbital, lowercase f, L value is 3. And next L is equal to 4 is G orbital and L is equal to 5 is H orbital. But the mainly we are using S, P, D and F orbitals, and their L values are, if it is 0 S, 1 P, 2 D, 3 F. So let's go to the shells again. N is equal to 1 shell, another name is energy level, only one subshell present, L is equal to 0, only S orbitals present. But N is equal to 2 levels, S orbitals and P orbitals both present because 0 and 1. N is equal to 3, S, P, D all 3 are present. N is equal to 4, S and L is equal to 0 means S, P, D, F all 4 are present. That is our second quantum number, angular momentum quantum number. It is 0 to n minus 1. Let's move on to our third quantum number, magnetic quantum number. Magnetic quantum number ML is the symbol lowercase m subscript l. So, magnetic quantum number relates to the orbital's orientation in space. For example, p orbitals, G orbitals. So, p orbitals normally exist as 3 p orbitals. They are degenerate. Degenerate means they have equal energy. They are equal in size, equal in shape and energy. So, equal energy 3 p orbitals, so we name as px, py and pc. So we named like px, py and pc because 3 p orbitals are along the 3 Cartesian axes. For example, if we draw the p orbitals x, y and this is c. So the p orbital, the dumbbell shaped p orbital are along the x-axis, we call px orbital. And the p orbital are along the y-axis, we call py orbital. And p orbital are along the c-axis, we call pc orbital. So always p subshell associated with 3 orbitals having degenerate equal energy. So we name they as px, py, pc because they are oriented in 3. They lie in along the 3 Cartesian axes. Now, what are the possible ML values? ML values are depends on L, angular momentum quantum number. For a given value of L, the possible ML values are minus L to plus L. Minus L to plus L. Let's talk about L is equal 0. What are the possible ML values? So, possible ML values are 0. Only 0. So, L is equal to 1. L is equal to 1. The possible ML values minus L, that is minus 1 to plus L, that is minus 1 to plus 1. Minus 1, 0, plus 1. And L is equal to possible ML values are minus L to plus L, that is minus 2 to plus 2, minus 2, minus 1, 0, plus 1, plus 2. And let's take another one. L is equal to 3. Possible ml values are minus L to plus L, that is starting minus 3, minus 2, minus 1, 0, plus 1, plus 2. So always ml values are minus L to plus L. To get the negative value of the L value to positive value of the L value through 0. Now let's see how we can relate ml values to this orientation in space. Let's make ml is equal 1, L is equal 1. L is equal 1 is for p orbitals. So p orbitals ml values are minus 1, 0, plus 1. So these three ml values are here, minus 1, 0, plus 1. Right? So they indicate the orientation, three different orientation in space. And the same like here, ml value is minus 2 to plus 2, 3, 5 different. There are 5 different orientations of d orbitals in space. And another important thing is how many possible ml values for a given L is given by this formula 2L plus 1. It gives the total number of ml values. Total number of ml for a given L value. We can calculate using this 2L plus 1. So that is our third quantum number, magnetic quantum number. Let's move on to fourth quantum number, spin quantum number. Spin quantum number symbol is M and subscript S. So spin quantum number can have two values. It can be plus half or it can be minus half. So here electrons can rotate by itself around its own axis in clockwise direction and in anti-clockwise direction. So depending on that, we consider plus half and minus half, two spin quantum numbers. For example, let's take one orbital. So in one orbital, one box, so we can draw the maximum occupancy of electrons is 2. So how we can draw the electrons? One up arrow and one down arrow. So if you draw up, up or down, down, that is not valid. So always in one orbital, the maximum number of electrons can occupy 2 as a one spin up and one spin down. So this spin up and spin down indicate that plus half and minus half. One electron plus half, the other one is minus half. Right, that is spin quantum number. So we discussed 4 quantum numbers. Principal quantum number that relates the energy level of the orbital. Second one, angular momentum quantum number that relates the shape of the orbital. Third one, magnetic quantum number that relates the orientation of the orbital in space. And last one, spin quantum number, that is about the electron spin, electron rotation either as clockwise or anti-clockwise. There are two possible values, plus half and minus half. In each orbital, 1 plus and 1 minus half. Now let's take few examples. So our first question is, an electron in an atom is in the n is equal 3 energy level. So list all possible values of L and ml that it can have. So let's talk about n is equal 3 level, that is nucleus in the middle, n is equal 1 level, n is equal 2 level, and this is n is equal 3 level. n1, this is n is equal 2 and 3 level. So what are the possible L and ml values? If n is equal 3, the possible L values are 0 to n minus 1. So it can be 0, 1 and 2. n minus 1 is 3 minus 1, 2. So it can be 0, it can be 1 or it can be 2. 0, 1, 2. That means L is S and L is 1 means P and D. All S, P, D are available in n is equal 3 level. Now what are the possible ml values? Possible ml values are minus L to plus L. So it can be, let's take the maximum, the larger number here, minus 2, and it end with plus 2. Minus 2 minus 1, 0, plus 1 and plus 2. So these are the possible L and ml values. Now let's see what are the meanings. L is equal 1 means only one s orbital. L is equal 1 means p, always p orbitals are as the 3 orbitals together, degenerate. So we can name them as minus 1, 0, plus 1. That is L is equal 1, P. This is S. Now what is L is equal to? It is d orbital. So always d orbitals are degenerate 5 d's. 3, 4 and 5. So that is minus 2, minus 1, 0, plus 1 and plus 2. So these L is equal to d orbitals. So each of these orbitals can occupy the maximum 2 electrons. One spin up, one spin down, and one spin up, one spin down, and so on. Maximum 2. So one electron is plus half, the other one is minus half, plus half minus, plus half minus half, and so on. Now this is the answer, possible L and ml values for n is equal 3. Let's go to next question. Next question is, indicate total number of p electrons in n is equal nitrogen. The atomic number is 7. And part B is s electrons in silicon. Z is 14. And part C is 3d electrons in sulfur. Atomic number 16. Now let's see how we can calculate. Total number of p electrons. Let's write nitrogen atomic number 7. C is equal 7. We can write the configuration 1s2, 2s2 and 2p3. So the question asks total number of p electron, that is 3 p electrons. So how we can draw the orbital box diagram? 1s2 2 electrons and 2s2 another 2 electrons, and p level there are 3 p orbitals always. Electron needs to occupy one at a time and then start pairing, so equally distributed electrons in p levels, that is 2p. That is orbital diagram for the nitrogen. In p level 3 electrons. Let's go to part B. Part B, silicon. Silicon, C is equal 14. So we can write electron configuration 1s2, 2s2, 2p6, that is 10 electron. Next electron fill to 3s2 and then 3p2. That is silicon, 14 electrons here. So the question asks about total s electrons. So s2 electrons in n is equal 1 energy level, and another 2 electrons is in n is equal 2 energy level, and another 2 electrons in n is equal 3 energy level. So electron distribution in energy level 1, 2 and 3 in their s orbitals, total is 6. Part C. Part C question asks about 3d electrons in sulfur. So sulfur atomic number is 16. We can write the configuration 1s2, the long version, or noble gas shortcut, 2p6, 3s2, 3p4. Now in this configuration, how many 3d electrons? So sulfur, no 3d electrons, 0. As no 3d electrons, still p level is filling, only 4 electrons, but maximum electrons can occupy in p level 6. 2 more needs to complete even p level, so no d electrons. Okay, let's go on to next question. Next question is, what is the maximum number of electrons in an atom that can have the following quantum numbers? N is equal to energy level or principal shell number, ms is plus half. So n is equal to means what are the possible L values? L can be 0, 0 to n minus 1 or 0 and 1. 0 means s orbital. So s orbital can occupy the maximum 2 electrons, 1 plus half, 1 minus half. And L is equal 1 means p orbital always occupied as 3 p orbitals. Each orbital can occupy the 1 plus, 1 minus, 1 plus half, 1 minus half, 1 plus half and 1 minus half. The question asks about in this n is equal to energy level, there are two shells, S and P, looks like this. How many m is plus half? So each up electron, the up arrow electron is plus half. So what is the total? 1, 2, 3, 4. There are 4 plus half electrons and there are 4 minus half electrons. 4 up arrows and 4 down arrows. Next, part B, n is equal 4 energy level, ml is plus 1. So let's talk about the possible L values. The possible L values are 0 to n minus 1. So it can be 0, 1, 2 and 3. So what are the possible ml values? ml values can be minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. The question asks about how many electrons. So here electrons in ml, these are the possible ml values. L is equal 3, that is S, P, D, F. There are 7 orbitals. Now let's talk about L is equal 1. ml value is 0. But starting L is equal 1, 2, 3, there are ml values possible. So let's talk about L is equal 1 level first. L is equal 1. Minus 1, 0, plus 1. So 2 electrons from here. ml is plus 1 requirement. And next one is L is equal 2. There are 5 orbitals. 3, 4, 5. So how we can name this? Minus 2, minus 1, 0, plus 1, plus 2. So each orbital 2 electrons maximum. The question asks about ml values plus. So ml plus is these 2 electrons. So I will use these 2 electrons plus 1, and again this is 2 electrons from p level plus 1. And next one is L is equal 3 level, that is F level. There are 7. 4, 5, 6, 7. So this is minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So again each one occupied maximum 2 electrons, spin up, spin down. So plus 1 belongs another 2 electrons here. Okay, now we have total 6 electrons. So the answer is 6 total electrons in n is equal 4 level that has ml values plus 1. So L is equal 0 level, ml value always 0, no plus 1. So we can ignore that. But starting 1, L is equal 1, 2, 3, all 3 subshells have L plus ml value plus 1. 2 from P and 2 electrons from D and 2 electrons from F. Totally 6 electrons have ml plus 1. Next one, N is equal 3 and L is equal 2. So N is equal 3, the possible L values. What are the possible L values? N minus 1 to 0. So L can be 0, 1 and 2. How many electrons in N is equal 3 and L is equal 2? So L is equal 2 means d orbitals. Always d orbitals occupied as 5 d orbitals with equal energy. So each d orbital can occupy the maximum 2 electrons. So 2 times 5. So 2, 4, 6, 8, 10. Maximum 10 electrons can occupy N is equal 3, L is equal 2 level. That is d orbitals. Okay, next question is n is equal to L0 and ms minus half. N is equal to L0 means s orbital. That is 2s orbital. So 2s orbital maximum can occupy 2 electrons, one spin up, one spin down. So one spin up is plus half, the other one is minus half. The question asks about how many maximum electrons can be minus half. The answer is only one electron can be minus half. Okay, our last one is n is equal 4, L is equal 3 and ml is equal minus 2. So n is equal 4, L is equal 3 means it is f orbital. So f orbital always occupy as a set of 7. 4, 5, 6, 7. So these L is equal 3 f orbitals. Possible ml values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. The question asks about L is equal 3, that means f orbital, ml value minus 2. So ml value is minus 2, only 2 electrons. 2 electrons minus 3 ml value, 2 electrons minus 2, 2 electrons minus 1, 2 electrons 0 and so on. So the question asks about how many total electrons in ml minus 2, that is this. I hope you will understand 4 quantum numbers and how we can find each quantum number in electron configurations for each atom. Thank you so much for watching.